So welcome. My name is Ewa Śniechowska, and I am supporting customers when it comes to providing security for cloud-native environments and for public cloud infrastructure. So nowadays we have more and more organizations moving forward when it comes to digital transformation journey and embracing this cloud-native world. And in every field, there are myths or misconceptions that develop over time. And I would like to use this session to tell you what are the most common ones and how to ensure that cloud infrastructure, cloud native apps are built and run securely, that all the business benefits cloud has to offer without compromising on security. So let's take a quick overview at what are the factors which led to changes when it comes to modern app architecture. So it is indisputable that software becomes much easier to manage when you split it into smaller chunks. So this approach is being used by most of the enterprises today, where they split applications they're providing into microservices. So without doubt, we see the increase of the container usage, and customers are moving from this monolithic architecture to microservices to provide decentralized approach when it comes to building software, and also gain flexibility, which is very much needed from the business perspective nowadays. And as a result, there is this breaking down of organizational silos in order to build this common operating model between IT teams. And collaboration between DevOps and security team is especially very much needed, so that to release software faster, but without shortcuts when it comes to security. And ideally, we should be making security part of the delivery process of software from start to finish, being integrated, automated, and not an afterthought. And if you also take into the account we have hybrid applications using, for example, both local DC and public cloud, and mix of different workloads, virtual machines, containers, serverless. It creates a set of new challenges and requirements when it comes to providing security for such environment. Going further, so we can ask ourselves, where in this modern application mess shall we implement security? So from an organizational point of view, DevOps was mainly focused on efficiencies and, for example, feature development, and traditional security has sat on the outside, a little bit isolated from development and operation teams. And those teams have dealt with different success metrics, different performance indicators, and so on. However, since modern apps and cloud environment became more complicated and more vulnerable, they require better risk management. And this brings this new world of DevSecOps, where modern architecture is forcing deeper integration between teams, partially because of using programmatic infrastructure, for example, also known as infrastructure as a code. It provides automation metrics and analysis to develop DevOps, DevSecOps practices. So there is kind of this mutual interest in decreasing the number of bugs, for example, across the different disciplines. And talking about vulnerabilities, there's quite a lot of them. Please take a look at the data coming from our Palo Alto Networks research. They clearly indicate that cloud adoption, different number of workloads in the application architecture brings quite a lot of challenges, mainly around vulnerabilities, compliance, visibility, dealing with automation. So no wonder that there is a certain confusion on how to proceed, especially from security perspective, which results in quite a bunch of myths. So let's cover some of them today. So first, is public cloud indeed more secure than a on-premise data center? So for cloud, we have something which is called a shared security responsibility model, which means that the provider takes some responsibility, but not all. So cloud service provider, when it comes to infrastructure as a code and platform as a service, for example, they focus on securing hardware, operating system, network, and the underlying infrastructure services. And actually, your security team should maintain some responsibilities for security as you're moving applications, data, containers, workloads to the clouds. Customer is the one who must define and enforce policies that, for example, securely enable business, remembering at the same time to align, for example, with goals and objectives and not to be a bottleneck when it comes to productivity. And unfortunately, cloud security breaches, they consistently make news and headlines. And yet the stories of these breaches are often framed with very vague explanations like misconfigured database or mismanagement by an unnamed third party. So sometimes it's actually hard to draw clear conclusions and learn ideally from others. It seems the challenge exists not in the security of the cloud itself, but in the policies and technologies for security and control of the technology. So in nearly all cases, it is the user, not the cloud provider, who fails to manage the controls used to protect the data. And we have to take into the account that cloud strategies usually lag behind cloud use. This leaves most of the organizations with quite a large amount of unsanctionable or unrecognizable cloud use, creating unnecessary risk exposure. And there is even a term called cloud security posture management, which is the approach of automating the identification and remediation of risks across cloud infrastructure. So this leads us to the second myth about using only security measures which are built into the public cloud. So I would like to focus on what you shall pay your attention to while choosing the security tool for such environment, rather than to tell you that this or that solution is bad, because this you have to actually evaluate on your own according to your needs, to your requirements. However, you have to remember first and foremost that most of the customers are actually choosing multi-cloud strategy. So if you have to maintain compliance, secure cloud native applications, and protect networks, enforce permissions, secure identities, and so on across different clouds, maintaining set of separate tools, each for different cloud, would be an operational nightmare. Also, for cloud native, those environments are constantly developing. So security requirements is going to be increased as well. And if we don't have a consistent strategy, ideally from the start, there is a threat that we can get lost because of the level of complication. We can miss or overlook something, which in worst case scenario will result in data breach, and which is pretty common as mentioned before. So the first step to a strong security posture is deep visibility. So once you know what resources you have in the cloud, where they exist and how secure each one is, you can actually enforce pre-built or customizable governance policies and guardrails which will keep your cloud compliant and secure. The way it's done in our case, it is using integration via API. And once we're connected to the cloud account, we will begin data ingestion. So resources from all accounts will be read, scanned together, config files will be brought in, APIs will be read, flow logs ingested, and so on, so that you have a very comprehensive view. And as soon as we have the knowledge about assets, we can check their configuration against compliance standards. So compliance standards listed here on the left-hand side would be very helpful to ensure that posture is fulfilled and maintained. You should have the possibility as well to customize those or build your own, and then map all the security policies needed into them. So having this on-demand view of the state of the cloud is very beneficial, and this can save hundreds of hours during audits and money as well. So to avoid potential troubles, it's good to have a snapshot of overall compliance posture across various compliance standards, regardless of how many different public clouds you are using. And it can be used as a tool, for example, for risk oversight across cloud platforms, which will, as a result, increase effectiveness of security processes and controls, which you are implementing in the enterprise. So additionally, it's a good practice to, for example, optimize policy creation for public cloud environment as well. So policies are created from security best practices, presenting in compliance standards and documents like GDPR, PCI, NIST, best practices, and so on. But what we do on our side is we codify these so that you can run them consistently across different clouds. And when a policy check is done and a policy violation is discovered, an alert is generated. Within the alarm, you will see, for example, information like how to fix it, which resources were affected. So it's not only information about the problem, but also the potential resolution. And on that topic, we can actually automatically resolve policy violations, such as, for example, groups. So to do this, we can run the command line command associated with the policy in the cloud environment, where it discovered the violation. However, please keep in mind that we're also able to create, for example, pull or push-based integration or additional communication with other products, including security centers working within public cloud providers. So you can actually enhance what's a native capability and rely on automation if needed, but within single pane of glass. So digging a little bit deeper on top of that, in our case, we have something which is called RQL, Resource Query Language, which is a very powerful and flexible tool that helps you gain security and this operational insight about the deployment of public cloud. So you can use RQL to perform configuration check on resources which are deployed on different cloud platforms, and also to gain visibility into user and network events. So it is also a language that we use to construct all of our policies. So both queries give you access to our engine. It shows you how we create policies, but also gives flexibility to customize those while pulling over detailed data which should be needed. Effect is, I can very easily search the whole infrastructure and do a specific drill down to search and identify potential misconfigurations or errors. In addition, if I would like to run such query 24 hours per week, right? I can copy this into the rule like discussed earlier, and we can get an alert anytime anything happens, right? So I can also get integrated, for example, with a ticketing system if needed for additional stuff. So we are also able to analyze, and it's pretty important to analyze network traffic flows to establish baseline for application behavior and detect any deviation from that. So since we are connecting to flow data, we can come back saying, in last days, here is all the traffic which passed through your network, and here are various hosts which we were able to correlate, where the IPs are coming from. Are they coming from internet, suspicious IPs? We have correlated that within threat feeds. On top of that, we are using machine learning to help you, for example, make decisions quicker and more efficient. So let me give you an example. Because we are monitoring CloudTrail or activity logs in public cloud, we can actually say, I want to see where my cloud account is in a certain cloud, how intense I am using it, and if by any chance, are there any incidents connected to user activity which should be monitored or taken care of. So we will look for examples like time travel incidents, location, activity change, login failures, brute force attempts, and so on. So to sum up, relating as well a little bit to myth number 1 and 2, public cloud can be secured provided you take responsibility, take a little bit different approach, and rely on a set of tools which are designed explicitly for that, adding on top what's delivered natively by the public cloud provider. So last but not least is adding security not only to the modern infrastructure, but to the process of developing software. So I mentioned at the beginning that cooperation between DevOps and Sec team is absolutely crucial, but it must be done with sense, right? So we would like to allow security and DevOps teams few things, like, for example, possibility to automate the creation of policy. saving teams time and this manual effort whenever it's possible. So gain a real-time visibility across the entire environment to the workload or container level, and to be able to confirm compliance with set of standards. Also, there is a need to prevent bad actions from occurring, both across the pipeline and running environment. So in order to truly enable the culture of DevSecOps, security teams need to empower DevOps with those purpose-built tools that integrate security seamlessly into existing workflow. So this allows DevOps teams to take responsibility for security in order to deliver applications with strong security from the start. And we believe in this shift left approach, meaning we should take security into the account ideally from the beginning phase. Developers should scan workloads using cloud-native security plugins and scan infrastructure as a code templates to, for example, find unsecure configuration used within Terraform, CloudFormation, you name it, and similar technologies. And security teams, however, should have the possibility to fail a build based on a vulnerability or compliance issues, preventing unsecure software from progressing in the pipeline and instead forcing the developer to resolve the issues. So, for example, metadata from an application along with tags can be used to notify the specific developer who created the app directly within development tooling they're already using. And as cloud-native environments, they become more automated, it's critical to ensure security teams can set and enforce these quality gates in the pipeline. So this way, no matter when or where a build was done, you can feel confident you're only developing a secure code. And to complement this for runtime security, DevSecOps teams should get an automated ranking, for example, for every issue sorted by risk severity, as well as how it impacts the environment. So for DevSecOps, being compliant and using benchmarks to provide checks and validate the recommended actions would be useful as well, since they provide best practices for configuring systems. So ideally, DevSecOps will have a compliance scoring system which lets them create compliance rules that take action depending on the severity of the violation and then act upon them if needed. So runtime protection is another challenge which DevSecOps teams have to handle. So in general, it is needed to ensure that processes that run in your environment meet the parameters of learned models and the rules defined. So to do this effectively, some portion of static analysis as well as machine learning is being used to model how each container image should be used. So in addition, they should define their policy by, for example, creating additional custom rules that target specific resources, enable or disable protection features, and define exceptions to the automatically generated allow list models when behavior, for example, is detected that deviates from your runtime policy, which is resulting from the combination of container model and your rules. And DevSecOps teams, they can proceed with an action then. They can manually or predefined or automate that action. So securing web apps and APIs is also a challenge from for security professionals. So the technology is constantly changing and existing web security solutions, they lack needed coverage. So teams should have the option to automatically identify protection status of web apps and quickly enable protection if needed, not to mention features like bot management, DOS protection, advanced analytics, coverage for OWASP top 10, file upload protection, and more. So to sum up, implementing security effectively for cloud native can be quite a challenge and requires different approach and addressing many new issues, which we didn't have to take care about at all, even recently. So we truly believe that public cloud and cloud native security can be secured, and DevSecOps teams can have sufficient tools to manage this demanding infrastructure as long as they have visibility and enforcement methods, regardless if the app is built on hosts, containers, serverless, maintained even in the multi-cloud environment. Thank you very much.